then I'll just say a very big hello and a very, very warm welcome to each and every one of you. I know that we know quite a number of your schools, but there are also schools on here that we are less familiar with, but that just shows the power of the Great Science Share reaching out into classrooms right across the UK. And this very, very special live lesson isn't just reaching out across the UK, it is going trans-international. We are reaching out to the USA, the United States of America, to welcome Richard. And so that's just showing how vast the Great Science Share is moving across the world. And we've got schools in Australia and across Europe also taking part. My name's Dr. Lynn Bianchi, and I'm the director of the Great Science Share. 6 years ago, this was a dream coming true, and over the past 6 years we've had more and more and more schools take part, which has just been excellent. But I don't do this alone. I do it with the most amazing team. I know they won't like me to say this, but I'm going to say it anyway. But we have Steph and Kate, who are actually the people who really have done the hard work in getting the Great Science Share to work this year. So I'll let Kate introduce herself, just because I know Steph's still trying to work some tech. So Kate, tell us who you are and what you've been up to with the Great Science Share this year.
Hello, yes, so as Lynn says, I'm the campaign administrator on Great Science Share. This year has been really exciting for me. We've been creating loads of video content like this. So yeah, lots of editing, lots of getting to meet people like you and your teachers, and seeing the questions come in.
Wonderful. And what you don't know about Kate is she got married last week, so we must all give her a big congratulations.
Thank
She's
you.
been waiting a long time because of COVID. So yeah, she is now, she's our first lady who's got married as part of the Great Science Share team. So congratulations, Kate. And over to you, Steph. Steph, what's your role and what do you do with the Great Science Share?
Oh, hello everyone, my name's Steph. I'm a campaign manager for the Great Science Share for schools, so I have lots of fun with the team trying to think of exciting things that will get you guys to be even more interested in science, some inspiration to get you thinking. So it's really great to have the Great Science Share for School happening tomorrow. We're just so excited that it all comes together, and yeah, it's great to see your faces because we're all sat in our houses alone doing this, so it's nice to get a view into some classrooms. So I hope you enjoy the session with Richard, a really inspirational person. So enjoy.
Thank you, Steph. Brilliant. And so to let you know, and to let your mums and dads and all your friends know, we will be editing this video. We are currently recording it. We will be editing it down, and then it will go out tomorrow as part of the Great Science Share, and it'll be there in actual fact for a long time yet, so that we can make the most of Richard's input today. And so you can watch it back and you can watch your questions being answered back as well. And that will be going out to hundreds of thousands of children tomorrow. So your role today is extremely special. You are one of only a few schools in the whole of the UK who have got this opportunity. So it's absolutely brilliant. And that's why I want you to turn your minds on, turn your ears on, and really engage and make the most of this, because what other experience are you going to have where you can meet and not only an astronaut, but a real explorer who has gone to space and also to the depths of the earth. So I think we're going to move on, as Richmond's still trying to come in, but I think we're going to move on, Richard, and allow you to share your screen and to start the presentation, and the other school will join when they can. Over to you, Richard.
Well, great. Well, thank you, Lynn, and thank you, everybody. Thank you, schools. I know many of your schools already because of the work we did before my most recent trip down to the Challenger Deep, but I will talk about that during my presentation. So let me first start by sharing my screen. I hope now you can see that today I'm just going to talk for a few minutes about my journey as an explorer. I also happen to be a video game developer, so I'm going to talk a little bit about both those, and then I'm going to go to answer a bunch of your questions as well. So I'm actually very, very lucky. I'm actually the first person who's been able to explore on the Earth all the way from the North Pole down to the South Pole, then also orbit above it from space. I lived on the International Space Station. And then most recently, the thing that I've connected to a lot of you before already about was my recent dive trip where I went down to the deepest place on Earth, to the Mariana Trench. But I'm actually a big believer in not just exploring, but also how exploring can inspire you as a creator, so that no matter what other business you are in or what other interests you have, that exploration can help feed that. And for me, it goes back, I think, to the upbringing I had. My mother was an artist, and so she taught me an appreciation for art and nature. My dad was an astronaut. He actually flew into space twice, first on Skylab, but then also on the space shuttle. And that brought me into my first career, which is computer games, because I think of computer games as sort of the high tech from my dad and art from my mom. And so that's if technology and art combined makes games. And so that image you see there is the simple dungeons from the very first game that I made back in the 1970s, a long time ago. I'm one of the very first people ever to make computer games. But I've made them, as I said, for 40 years. I've been making video games. The word avatar comes from my games. Massively multiplayer games comes from my games. But the same time I was making video games, I was already starting to become an explorer. And I had taken myself as really what you might think as vacations. I took my vacations into very unusual places, like riding down the Amazon River or going into Africa to go visit mountain gorillas. But as my career grew, I then used the results of that career, my income from that career, to help open exploring more and more extreme environments. And so even though I've had 3 computer gaming companies, I've started even more exploration companies that I'll talk about some of those. And so I helped start companies that would help take people down to the South Pole, a company that would take you into zero gravity, a company that could charter submarines to take you down to deep ocean targets. And what I found as I began to really go to these extreme places is there was really interesting science I could do. For example, something I've done in almost all of my recent trips is look for extremophile life forms. These are microbes, things you can only see through a microscope, but little bugs that you can see, some of which that live in very cold environments, some that live in very hot environments, even as hot as the vents of volcanoes, some that live in the deep ocean, some that even live at the poles. Like we found some in the samples we took both from the South Pole and the North Pole. But for me, I always really wanted to go to space. To me, space was the big target, the place I really wanted to go. But one of the NASA doctors told me that because I needed glasses, I wasn't going to be able to become a NASA astronaut. And so I said, wow, that made me very sad. So I decided I was going to have to build my own space agency. And so at the age of 13, literally only 13 years old, I decided I was going to make my own space agency. And I started building companies, and a lot of them did not work. But the story for this was, if the time that I tried to make it work failed, I then sat back and said, wow, did I learn enough by that first attempt that I can try again? And I always felt that I had learned enough, and I felt I could try better a second time. And so I tried over and over again until, most interestingly, we started something called the X Prize. The X Prize was a prize to pay for the first private spaceship to fly into space. In 2004, that was won by this vehicle that now hangs in the Smithsonian Museum called Spaceship One. And that opened the door for commercial human spaceflight. And so eventually in 2008, so 12 years ago, I finally achieved my dream of going into space. And I did lots of experiments in space. That's just a list of the experiments. But one of the most interesting ones was growing crystals of things called proteins, of molecules called proteins. And it turns out by growing these crystals in space, you can actually provide images of those proteins that you can't do on Earth. So it's actually very valuable to do this work in space. But then most recently, in fact, literally just March 1st this year, I went down on my final spot of my, north to south to orbital to deep, was just this last March, where I went down in this submarine called Limiting Factor to the bottom of the deepest place on Earth, which is called the Mariana Trench. It's in the middle of the Pacific Ocean. It's where 2 tectonic plates are moving and pushing against each other and then pushing each other deeper and deeper. I spent almost 2 weeks aboard this research vessel called Pressure Drop. The day that we go dive, we first drop these 3 what are called landers down to the bottom. These sort of make an underwater GPS for us to navigate with at the bottom of the ocean. We then haul the 10-ton submarine off the boat, climb into it, and descend 4 hours down to the bottom. And then finally, when you get to the very bottom, you're in what we originally called the abyssal plain. And this is at 10,925 meters, almost 11 kilometers down below the surface of the ocean, where there's just an immense amount of pressure. And we then we spent 4 hours exploring around on the bottom. Unfortunately, we did almost every dive. We see trash that's down there at the bottom, even scientific trash. This image is a bit hard to see, but you can probably in the bottom right see some little curly coils of white plastic wire. That's actually scientific trash that was dropped by another scientific research team, less than a year before we dove down there. And then we go over and we visit those landers. And when we go visit those landers, you see all the life that has come to check those out. And so we saw these little like shrimp-like creatures called amphipods. Let's say these little tube worms attached to some of the rocks. These siphonophores, that red thing in the bottom. We actually bumped into one of those on the way up from the bottom. And of course some fish down there at those depths too. And of course for a lot of some of you probably, I took down a whole bunch of art that students had created, and I took down a bunch of poetry that some of you had created. In fact, I was so inspired, I wrote some of my own poetry, even about my Lego submarine that I took down there with me. And then it took 4 hours for us to return to the surface. And then once we get on the surface, we then start doing research on some of the samples and data we brought back. Like, so there you can see on the left-hand side, you can see some of the little amphipods we brought up. On the right, you can see some of the microplastics that we found in both the water and in the creatures that we brought up from the deep. And then even though I have now been returned, so it was March, so it was a couple of months ago when I went, but we are still working on that data to this day. For example, the water samples and how much plastic is in those water samples, that research is still not finished. So I can't even report what the final data is on that. That'll probably take all summer before we really know the final measurements. But it is very clear that there was a lot of plastic down there at the bottom of the ocean. So thank you very much. That's just a kind of a brief introduction to me as an explorer. And with that, I'd love to pass it back over and take questions directly from the students.
So fascinating, Richard, and seeing the photos there as well just makes it so real. I'm personally really intrigued by the different animals that you saw down there, and that's, sorry story really, isn't it, about the plastic waste that you see. We hear so much about that, but obviously we don't see it with our own eyes, so it's really important that we see it through yours.
Yes, and what I think is interesting about that, I think, young people today, I think, do understand that plastic in the ocean is a big deal. And I know you all have had some really interesting projects about that. But I think that, if you think of the problems that all of us really need to be thinking about these days, global warming is obviously a really big one that is affected by another really big problem, which is where are we going to get our energy from? And then that is related to a problem, which is how are we going to get enough fresh water for us all to drink and grow all the crops we need to provide the food we need for all 7 billion people on this planet. And then at the same time, you then look out into the oceans, and not only are we both consuming all of the biodiversity of the earth, we're either eating it or killing it off with the pollution, but also these plastics that are getting down there in the bottom of the ocean now. That's probably just the latest of these really big problems. So that's, I just named about 5 really big related problems that these kids are going to be going to get to be the leaders, the scientific leaders that figure out some of these big problems. And so some of you are going to get a chance to really make important contributions to the health and prosperousness, the prosperity of humanity here on Earth.
Indeed, and that will go well beyond you and I, won't it, really?
It will.
Okay, So we've had a bit of an input there from Richard, and we know that you've been looking at Richard's profile and possibly watching some of the videos as well that are linked to his latest mission there. So, and I know that we've already had some questions sent in, so your teachers have been working really hard with you to gather those questions. And so we expect that there'll be a few people nominated from the classes to be able to unmute and to ask Richard those questions. So what we're going to do is going to go around each of the classrooms now, and hopefully we'll get a really great flavour of the questions. If something is of interest to you that other people say and you want to ask a further question, of course, you're very welcome to do that. You can use the chat function for sure, because that can take, there can be lots of commentary going on there as well. So teachers, you might want to type into the chat if you're hearing comments or interesting things coming from your pupils as well. So please actively use the chat as part of this whole experience as well. So I think, and I'm just seeing that there's just one school who is unmuted at the moment, so we might as well jump to them straight away. So if we do it this way, and we'll do Christ the King, then we'll go to Abraham Moss for blue, then we'll go to Meriden C of E, we'll go to Road Heath, and then we'll go to Abraham Moss for yellow. If I can make sure I remember that way around, I'm sure you will, so that you know when your turn is coming up, and really listen out to the answers and the questions coming up. So Christ the King, you're, you know, as a teacher, you are sitting beautifully. So have you got your nominated speakers to ask some questions to Richard?
We have, thank you. There's three at the front.
Okay, go ahead.
Grace, Harry and Sammy.
What was the hardest part about exploring the Mariana Trench?
Say it loud. Say it loud.
What was the hardest part about exploring the Mariana Trench?
Yeah, so that's an excellent question. So interestingly, most of the hard part about going down the Mariana Trench happened before we get to the Mariana Trench. You know, the submersible that goes down to that depth has a hull that is 9 centimeters thick of titanium. And so to build that hull to keep us safe from the pressure, which is 1,000 times greater than at the surface, is very, very difficult to do. And so the construction of the submersible, the staging of the ship, moving all this material out to Guam, out in the middle of the Pacific, all of us getting on board, spending 2 days traveling above the deepest point on Earth. And then it took a crew of 35 people to operate that submersible and get it down to the bottom. Once it came time to get on board, that was actually relatively easy. The hardest part for me was I actually had to work out ahead of time to get into the shape that I wanted to be in, to both physically get in and out of the submarine, which is actually somewhat difficult to get in and out of, and to be prepared to sit in a very, very tight, confined seat for 12 hours to the bottom and back. But most of the hard work was done before we started. That's a fascinating question. Thank you. And Lynn, you're muted.
Sorry, yeah, spotted. Christ the King, do you want to ask one more of your questions and then we'll move to another school? Did you get the answer that you were interested in there or wanted? Is that good enough for us? Okay, you've got a nod, Richard. That's all right. Okay, anyone else? And then we'll come back to you a bit later on. And what's another question? Shout it out.
What inspired you to go exploring in the Challenger Deep?
What inspired you, Richard?
Oh, yes. So it's interesting. When I first joined something called the Explorers Club, in fact, I'm wearing the shirt of the Explorers Club, and actually just another couple months ago, I was made the president of the Explorers Club. But when I first joined the Explorers Club, one of the first people I met was an explorer by the name of Don Walsh. And Don Walsh and his diving partner, Jacques Picard, were the first people to ever go down to the Mariana Trench. And they went down there the year before I was born. And I'm about to turn 60 years old. So it was a long time ago when they made the first trip down there. And since then, only one other vehicle prior to the vehicle I went in has ever been down to that depth. And that took a filmmaker, the filmmaker named James Cameron went down in a one-person submersible about 20 years ago. And so I actually never thought I'd be able to go to that depth. So few people had ever been down there that I never imagined that I would get a chance to go. But then a fellow explorer, someone I know through the Explorers Club, decided to build this submersible. And he built it in a way not to just go once. Those previous machines could only go one time, and they were actually ruined, in that one dive. They were damaged so badly by their one trip to that depth, they couldn't be used again. And so Victor Vescovo was the builder of this ship. He made it to where it could go down there repeatedly. And so after he went down by himself first to be the third person to ever go to that depth, or the third dive, fourth person to go to that depth, he then called the rest of us explorers together to help put together a science program that we would all help support, as we also all got to go dive with him down to the Mariana Trench. So I feel very lucky that I got to follow in the footsteps of really one of my greatest inspirational exploration heroes, Don Walsh.
Okay, so there's something to look into. Don Walsh, I wonder whether you can find out more about him, and I wonder whether anybody out of your class, Mr. Nolan, can tell us which scientists they're inspired by. They got any names that they'll inspired by particular scientists, perhaps?
Scientists. Oh, yeah, Maggie Adair Pocock.
Ah, fabulous. Right, a female scientist, even better.
Yeah,
yes,
we learned about her at the beginning of the year. So, yeah, we spent some time looking at space.
Excellent. Yeah. All right. Steph, do you want to take over?
Okay, so I think we said we'd go over to Abraham Moss for blue next, if you're ready. We might just ask each school one question now, just to make sure everyone gets a try. If we've got extra time, we will come back to you though. So Abraham Moss for blue, whenever you're ready.
What is your greatest challenge that is about space?
Oh, the greatest challenge about space. So traveling into space, was much more difficult to train for than training to go down in the submersible. Although they have a lot of similarities, both the submarine and the spacecraft that I flew in, to breathe, you have to add oxygen, you have to subtract carbon dioxide, you have to keep the pressure close to 1 atmosphere, you have to manage the temperature. And so they actually have very similar life support systems. But on the space station, there were a lot more things I had to learn about safe operations. So there's very complicated radios. Any of the experiments we did required, more significant training. Since I was there for 2 weeks, I had to learn how to operate even the things as normal as a space toilet. I had to learn how to operate the kitchen and the toilet, and so there were a lot more safety procedures to go through as well. And so it took me about 1.5 years to train for my trip to space, where I only really had to train for a few days to prepare for my submersible trip. How's that?
Thank you, Richard. Thank you, Abraham Moss for blue. That was a really interesting question. So we're going to go over to Meriden next. Are you ready, Meriden C of E?
Yep, we're ready. What's been your scariest moment?
Oh, the scariest moment. Interestingly, as an explorer, my scariest moment didn't come from the most extreme exploring I've done. Even though there were alarms that went off when I was in space, and I've been stuck at the bottom under the Titanic in a submarine, and I've been stuck in the Amazon, and I was even stuck for an extra week in the interior of Antarctica due to bad weather. But the scariest was actually something I did myself. It was a mistake that I made doing something much simpler, which was called rappelling. I was with some friends on a big rock cliff face where we had put ropes down, and we were attaching a harness to it to go down, up and down this cliff by ropes. And one of my friends, who's a lot stronger than I am, found a crack along the top and just started going down it by hand. And I followed him over the edge going, if he can do it, I can do it. And as soon as I got over that edge, I realized I can't do it. But it was too late. I was already over the edge, and I didn't have a rope, and there was no way for me to get back up. It was very difficult for me to get down safely. And so obviously I did eventually make it down, but only after finding a way to rest by putting my arm inside the crack It was really easily the most dangerous place I've been, and frankly, it was a bad judgment on, it's the worst judgment I've ever had from an explorer standpoint, to needlessly have put myself in so much danger.
Wow, thank you, Richard. No, that had my heart pumping a bit then, just the thought of being in that situation. So thank goodness you managed to come through that, and you can talk about it now. Brilliant. So we're over to Road Heath next, please. Mr. Scott's class.
I have got Hannah coming up to the camera to say hers. So come really close, Hannah, nice and loud, please.
What would happen if we colonized Mars?
Oh, Hannah, that's a great question. I'm actually a big believer in humanity moving into space and onto the surface of other planets, or into space stations, large colony-sized space stations. One of the challenges of living on Mars, well, there are many challenges to live on Mars. Some are easily solved. For example, you would need to be able to breathe. You have to be under a pressurized dome. To have enough water, you'd want to build your habitat near one of the poles where there's lots of ice that you could melt for water to drink, and to split that water into oxygen to breathe and hydrogen for fuel. But one of the biggest dangers is radiation. Here on the Earth, we're protected from the sun's radiation, the most harmful parts of the sun's radiation, because of the magnetic field that our Earth has around it. And we have a magnetic field because the core of the Earth is molten iron that is whirling, that creates a magnetic field. Well, Mars is smaller than the Earth, and it cooled faster than the Earth. And so it's what was a molten core has now turned to solid iron instead of molten. And so it has almost no magnetic field. And so to live on Mars, the biggest problem is you can't live on the surface exposed to the sunlight. You have to actually live not only under a dome, but under the ground. You'd have to either pile up a lot of dirt on top of your dome, or go actually literally into a cave under the ground to protect yourself from the extremely high radiation on the surface of Mars. But I still think it needs to be done. I still think it's worth doing, but it's going to be very, very difficult.
Thanks, Richard. Hopefully that answered your question, Hannah. And we're over now to 4 yellow, Abraham Moss, please.
However you've been, what was your favourite place you've explored and why?
Oh, that's a fantastic question. Interestingly, until I had gone to space. So, well, the short version is, space is by far the most interesting place I've been. It is profoundly life-changing to get the chance to orbit above the Earth in space and look down at the beauty of the Earth and just feel like there's a constant fire hose of information about the world we live in just by looking out the window. But prior to going to space, and still to this day, on the surface of the Earth, by far the most profound place I've ever been is the interior of Antarctica. And what's interesting about that is in the interior of Antarctica, other than what you bring with you, there's only the air, ice, and rock. That's it. There's no plants, there's no animals. It's all there is ice and rock and the invisible air around you. And despite that, it's the most profoundly beautiful place I've ever been. The sculpture of how the wind and eons of weathering has changed that landscape and shaped that landscape, and how much the laws of physics just seem to change while you're down there is really just profound. But then if you get closer to home, like in next month, I'm going to some islands off the coast of Portugal called the Azores. And I find the Azores to be just an exceptionally beautiful destination too, which is much closer to home. It's only a couple-hour plane ride there from you all in London.
Thanks, Richard. That's brilliant. And I've seen we've just got the exciting addition of Richmond Avenue Primary School. They've been on a bit of a mission trying to join in with us this afternoon. So I'm really pleased to see you having a lovely wave there. So if you're ready, Richmond, we can have a question from you. Over to you. I'm so sorry we can't hear you. We can see you, but we can't hear you. Would you like to type the question into chat so that Richard can read it and answer it for you?
We did hear you a second ago, so I'm not sure why we've lost you now.
Yeah, I don't know if your microphone has a mute button on the microphone. Now you're muted as a channel. Now you're open as a channel, but does your microphone have a separate mute?
Well, it's lovely that you can hear us. I'm just keeping an eye on the chat to see whether you want to pop your question in the chat. And thank you for Christ the King, popping some more questions in that. And Abram Moss 4 Blue. Oh, is it there? Yes, it is. Richard, the question for you today is, which job is harder for you to train for? Being an aquanaut or being an astronaut? Great.
Yeah. Interesting, you know, and I've talked a tiny bit about this, where I described that a lot of being an astronaut and being an aquanaut are similar in the sense of the life support systems are frankly almost identical. You know, on the inside of the spacecraft, on the inside of the submarine, you need to manage the air pressure to stay at 1 atmosphere, because if it gets too low, then you pass out, ultimately could die. And if it gets too high, nitrogen and oxygen both become dangerous to you. So you need to keep it at 1 atmosphere. You need to add oxygen to continue to have oxygen to breathe. You need to get rid of the CO2, or it becomes, the pressure goes up, or it becomes too prevalent in the mix. But the submarines usually only stay underwater for less than a day, just because you need to come back to the surface and recharge the batteries and do other sort of maintenance. And so you don't, for example, have a bathroom, and you don't have a kitchen, and you don't have very many experiments on the inside of the submersible with you. On the other hand, for space, since you generally stay there for days, if not months, you have a lot more equipment to learn about that isn't just the life support. Most of the experiments are inside with you. Most of them last, weeks, if not months. And so there's a lot more training and safety training and things of that nature that go on for space training. But there's still a lot of overlap, amongst those systems. So they're both, frankly, they're both great fun. So you would enjoy training for either one.
I wonder which one the Richmond pupils would like to have been the most. I wonder, aquanauts or astronauts. Maybe they can have a think about that and share it with us tomorrow as part of the great science.
Or they can just use your finger and point up if you'd rather go to space, and point down if you would rather go to the deep sea.
Let's see, everybody could do that, couldn't they? Where would you like to go?
Oh, actually, you got a mix of both. Yes, there's a lot going both directions. So, wow. So, so that's fascinating. So, yes, we've got both. We got a lot of great astronauts and aquanauts in these classrooms. That's fantastic.
Okay, excellent. So, Steph, where next, do you think?
So we've had a couple of questions that have popped into the chat. So maybe we could go back to maybe we should go back to Mr. Scott at Road Heath if he wants to ask the follow-on questions they had about the aquanauts and going down in submarines.
Yes, do you want me to say some of the ones on the chat? Yeah, George, do you want to come up to the front, and Henry? George, you want to come first? So nice and loud, George. Now come close to the camera. So what's your question, George?
What is the deep? How far is the Mariana Trench? Like how far down is it?
Yeah. So what's fascinating is, if you think of the world's oceans, of course they start very shallow at the beach. Is where they become quite shallow. But then when you just get a few hundred yards or maybe a couple of miles offshore, the oceans become very, very deep, very, very quickly. And the pressure, once you get below just a couple hundred meters, is so great, you can't even scuba dive into it. So you really need a submarine. And most submarines, including military submarines, only go down a few hundred meters, only like 300 meters. And so almost 95% of the world's oceans are much deeper than that. And so I had already been going down in submarines very much like this one here. I've been going down and there's a pair of submersibles called the Mir submersibles. It looks something like this. And these submarines, and there's a few others like it, that can go down to 6,000 meters. And so I've been down to 6,000 meters, or approximately, maybe 6 different times. But that's as deep as any submarine has been able to go, except for the 3 in history that have ever gone deeper. And one of them is the one I just went in, which is what's described as a full ocean depth submersible. And so it can go to the deepest point anywhere in the world, and that is 10,925 meters, which is how deep I went. Almost twice as deep as this other one had gone, and it can do it not just once, but do it every day. And so it's really exciting that only now, just literally now, is the 80 to 95% of the world's oceans which are completely unexplored. We now finally have a machine that can go explore it.
Well, thank you, Richard. That's really interesting. It's just mind-boggling to think how deep that is. It's hard to even imagine it. So we had a question came through from Richmond Avenue, and I know Abraham Moss had put this in the chat as well, and it's something that I think we'll all find really interesting. So Abraham Moss for Blue, do you want to ask your question about space and what the astronauts might be up to when they're there?
How do you eat in space?
Was the question about how far up in space do we go?
How do you eat in space?
Oh, how do you eat in space? Oh, well, that's what's fascinating. So, it's interesting that when you are in orbit, everything that is with you is floating inside the space capsule. And so, for example, if I were to let go of this bottle, right now it, of course, would fall onto the floor or my desk. If I were to let go of this bottle while we're in orbit, it would stay floating here in front of me. And the same thing is true for food. And so, for example, if I just tried to tip up this bottle to drink water out of it while I was in space, I wouldn't get any water out of it because gravity is helping to pull that water from the bottle into my mouth. And so to drink the water out of a bottle, you have to use a straw. And in fact, if there's a brand in the US called Capri Sun, a little plastic bag that you put a straw in to get some juice out of. The things you drink in space are like that. There's a straw into a bag. But then food is a similar problem. Like if you open up a bag of potato chips or open up a bag with little candies in it, they immediately start floating away. And it's actually hard to catch them all because you bump them and they actually go away even faster. And so most of the food that we prepare in space is food that is sticky. And so, for example, macaroni and cheese would be a really good dish to eat in space because then you can use your spoon to scoop out a piece of macaroni and cheese, and the macaroni and cheese will stick to the spoon until you get it in your mouth and can scrape it off the spoon and swallow it. And so drinking with straws and eating food that is sticky is actually one of the main challenges for eating and drinking in space. That's an excellent question. Thank you.
Oh, what an excellent answer. I wonder how many children can go home tonight and decide, is their food, is their tea tonight something that Richard could eat in space? If it is, take a photo of it, have a selfie with your meal and share it with us, because that is just another way of sharing your response to part of today's session. So that would be quite fun to see.
We had a couple of follow-up questions pop in. Obviously, the thought of food in space has inspired a few of the children. So can you feel the food in your stomach? Can you feel it floating around? And are there certain types of food you have to eat? That's from Richmond Avenue.
Well, hey, folks from Richmond, that is actually a more interesting question than people might think. So while you don't feel it floating around in your stomach, what is interesting is that is related to a question that I took some student questions with me on my trip to space. And one of the questions, which, by the way, this is a Snapple juice cap that I keep here on my desk because it has the question on it. And the Snapple answer in the cap is wrong. And so the question that a kid asked me was, can you burp in space? Mm-hmm. And I thought that's an interesting question because the food and drink will float around in your stomach. And here on Earth, gravity will pull the food and water to the bottom of your stomach. And so any gases will float to the top. And so when you burp, you would burp the gas. Whereas if you stand on your head on Earth, you might throw up instead of burping, if you tried. And so I thought, that's a fascinating question. So I'm going to find out. I'm going to do the experiment that this kid had asked me to do. And it turns out when you get into space, the first time you try to burp, you can't burp without burping some liquid up into your mouth. So it's really dangerous. But as it turns out, after a few days of being in space, your body figures it out. Your body figures out how your esophagus can knead the food and liquids downward and allow the gases past it. Your body learns how to differentiate that. And pardon my description, but just like the same way that if you think about gases that come out the bottom of your body, that works, your body figures that one out despite gravity being not particularly helpful. And it turns out for your throat, it does the same thing. And so even though the Snapple cap says you cannot burp in space, that's wrong. You actually can learn to burp in space, but it just takes a few days.
That's fabulous. Not something I thought I'd learn this afternoon, Richard, but that's absolutely wonderful. And an insight that we would only gain from a true explorer like yourself. Okay, how are we doing with other people's questions? Have people still got questions that they want to ask? We've got hands up from Abraham Moss for blue. Are we happy to go with them? And then we've got another one in Mr. Nolan's class. How are we doing for time, Steph?
Well, time's nearly up, really. So we could probably have another question, but I think maybe just to make sure everyone's had a similar amount of time, if we could go to Meriden.
Okay, good idea. We got any other questions from Meriden, Mrs. Evans?
Yes, we do. Lizzie's got a question.
Do you ever go on a normal holiday?
So Lisa, that is a great question, and I would say yes. I'd say in the majority of our holidays, like anyone else, are either to go visit with family or get together for meals with friends or family, and we do some normal things like take a vacation to a beach or or other things of that nature. But usually at least once a year, I try to go on a much more serious expedition. And when possible, I try to do it with my whole family. But sometimes I can't. So like, for example, this trip down to the deepest point in the ocean was on a scientific research ship that my two children it would be unsafe for them to be on board because it doesn't have like railings around it as a normal cruise ship would to make sure people don't fall off into the ocean. In fact, there were the sides of the ship where the submersibles come on and off or the landers going on and off had no railings at all. So you had to be very careful. So I went by myself. On the other hand, it turns out it's actually a lot easier to get to the North Pole now than it used to be. And so we actually flew airplanes and helicopters to get there. And so in this case, I took my kids. And so my two children, who 3 years ago when we went, they were 3 years old and 5 years old. They're the youngest two people to have ever camped out at the North Pole. And so we stayed overnight. Actually, we stayed over 3 or 4 nights at the North Pole. And that's just because it's possible to do that one safely now, even with young people. Whereas it wasn't, obviously tens of years ago, it would have been completely dangerous to take young people. But I still would have gone, but by myself.
Thank you, Richard. So I think we've just about ran out of time, and I know it's the end of school day, so a lot of people will have to start making preparations for home time. So I think if we could just say a massive thank you to Richard for his time with us today. So maybe you could unmute and give him a little cheer and a clap.
Thank you. Brilliant.
Excellent. Yes, thank you.
You're welcome. You're welcome. So excited to be with all of you too.
Yeah, thank you so much. We have never had an astronaut on the Great Science Share for Schools, and we really hope that you'll keep in touch with us and spread some of the love across the United States of America, where you are at the moment. And hopefully be in touch. And there's a very big thank you also to Heather McRae. She's been very quiet on this call, but she's been the person who's orchestrated this partnership to come together, and Heather works for the Ideas Foundation, but I know she's been doing this because she's massively passionate about STEM, about space, and she's brought this connection to us. And so I say thank you on behalf of our team and also on behalf of all of the schools and the pupils that have engaged today.